According to the 2023 National Electrical Code, specifically Article 408.21b, subpanel must be rated for at least the sum of the branch circuit ampere ratings supplied by that subpanel. In a situation presented, the main panel is rated for 100 amps, 3-phase, and there is a plan to install a subpanel to supply lighting. The lighting panel itself is rated for 100 amps, 3-phase. Therefore, the calculation for the subpanel rating necessitates that it must be at least 100 amps. The conclusion is that a 100 amp subpanel can be installed in this particular scenario. However, several additional considerations should be taken into account. Firstly, it is essential to check local codes for any additional requirements that might be in place. Local regulations can sometimes be more stringent or have specific amendments to the National Electrical Code. Secondly, ensuring that the subpanel has the appropriate circuit breakers is crucial. These circuit breakers are necessary to protect the branch circuits that are fed from the subpanel. Thirdly, a thorough load calculation for the lighting panel should be performed to ensure that the subpanel is adequately sized to handle the anticipated load. This load calculation involves determining the total amperage that the lighting circuits will draw under normal operating conditions. It's vital to understand the fundamental principles of electrical panel sizing and subpanel installation to ensure a safe and code-compliant electrical system. The National Electrical Code serves as the primary guideline for electrical installations, aiming to protect people and property from electrical hazards. Article 408, which covers switchboards and panel boards, provides specific requirements for the installation and rating of these components. The specific section, 408.21b, focuses on the rating of subpanels relative to the branch circuits they supply. The requirement that a subpanel must be rated for at least the sum of the branch circuit ampere ratings is a critical safety measure. This ensures that the subpanel has sufficient capacity to handle the maximum potential load of all the circuits connected to it, preventing overloading and potential overheating, which can lead to fires. In this context, the term branch circuit ampere rating refers to the maximum current that each individual circuit breaker in the subpanel is designed to carry. For example, if a subpanel has 10-20 amp circuit breakers, the sum of the branch circuit ampere ratings would be 200 amps. Therefore, according to the NEC, the subpanel would need to be rated for at least 200 amps to comply with this requirement. When selecting a subpanel, it's also essential to consider other factors beyond just the minimum ampere rating. These factors include the number of available circuit breaker spaces, the type of enclosure, and the interrupting rating of the circuit breakers. The number of circuit breaker spaces should be sufficient to accommodate all the necessary circuits, with some spare capacity for future expansion. The enclosure should be appropriate for the environment in which the subpanel will be installed. For example, in a damp or wet location, an M3R rated enclosure would be necessary to protect the internal components from moisture. The interrupting rating of the circuit breakers refers to the maximum amount of fault current that the circuit breakers can safely interrupt. This rating should be high enough to handle the potential fault current available at the installation location. Performing a load calculation for the lighting panel is a critical step in determining the appropriate size of the subpanel. This calculation involves adding up the total amperage of all the lighting fixtures and other electrical devices that will be connected to the panel. The NEC provides specific guidelines for calculating these loads, taking into account factors such as the type of lighting, the square footage of the area being lit, and any applicable demand factors. Demand factors are multipliers that can be applied to the total load to account for the fact that not all electrical devices will be operating at their maximum capacity simultaneously. For example, in a large office building, the demand factor for lighting might be 80%, meaning that only 80% of the total connected lighting load is expected to be in use at any given time. After calculating the total load, it's important to add a safety margin of at least 25% to account for future expansion and unforeseen loads. This safety margin ensures that the subpanel will not be overloaded if additional lighting fixtures or other electrical devices are added to the panel in the future. In addition to the NEC requirements, local codes and regulations may also impose additional requirements for subpanel installations. These local codes can vary depending on the jurisdiction and may address issues such as the type of wiring methods allowed, the grounding requirements, and the need for inspections. It's always a good practice to consult with a qualified electrical contractor or local building inspector to ensure that the subpanel installation complies with all applicable codes and regulations. Proper grounding is another critical aspect of subpanel installation. Grounding provides a low impedance path for fault current to flow back to the source, which helps to trip the circuit breaker and prevent electrical shock hazards. The NEC specifies detailed requirements for grounding electrical systems, including the size and type of grounding conductors, the methods for bonding metal enclosures, and the connection to the grounding electrode system. The grounding electrode system typically consists of a ground rod, a metal water pipe, or a concrete encased electrode, which is connected to the earth to provide a stable reference point for the electrical system. When installing a subpanel, it's important to ensure that the grounding system is properly connected to the subpanel enclosure and to the neutral conductor at the main panel. This connection helps to maintain a consistent ground potential throughout the electrical system and prevents voltage differences that can cause electrical shock hazards. Furthermore, it is important to use properly sized conductors when installing a subpanel. The conductors that feed the subpanel must be sized according to the ampacity requirements of the load, as specified in the NEC. The ampacity of a conductor is its current carrying capacity, which is determined by its size, material, and insulation type. The NEC provides tables that list the ampacity of various types of conductors under different conditions. When selecting conductors for a subpanel installation, it's important to consider the ambient temperature and the number of conductors bundled together, as these factors can affect the ampacity of the conductors. In addition to the conductors that feed the subpanel, the branch circuit conductors within the subpanel must also be properly sized. These conductors must be sized according to the ampacity requirements of the circuits they supply, taking into account the type of load and any applicable directing factors. Proper overcurrent protection is also essential for subpanel installations. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices are installed in the subpanel to interrupt the flow of current if the current exceeds the rated capacity of the circuit. The NEC specifies detailed requirements for overcurrent protection, including the size and type of overcurrent devices, the location of the devices, and the coordination of the devices with the conductors and equipment they protect. When selecting overcurrent protection devices for a subpanel installation, it's important to choose devices that are properly rated for the voltage and current of the circuit. The devices must also be listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories, to ensure that they meet safety standards. Another important consideration for subpanel installations is the proper labeling of circuits. The NEC requires that all circuits in a panel board be clearly labeled to indicate the purpose of the circuit. This labeling helps to identify the correct circuit breaker or fuse when troubleshooting electrical problems or performing maintenance. The labels should be durable and easy to read, and they should be updated whenever circuits are added or changed. In addition to the technical requirements, it's also important to follow safe work practices when installing a subpanel. These practices include energizing the circuit before working on it, using appropriate personal protective equipment, and following lockout/tagout procedures to prevent accidental re-energization. Working with electricity can be dangerous, and it's important to take all necessary precautions to protect yourself from electrical shock hazards. Finally, it's important to have the subpanel installation inspected by a qualified electrical inspector. The inspector will verify that the installation complies with all applicable codes and regulations, and will identify any potential safety hazards. An inspection is an important step in ensuring the safety and reliability of the electrical system. To summarize, when installing a subpanel for a 100 amp 3-phase lighting panel, it's essential to follow the requirements of the National Electrical Code, as well as any applicable local codes and regulations. These requirements cover a wide range of topics, including the size and type of conductors, the overcurrent protection, the grounding, and the labeling of circuits. By following these requirements and safe work practices, you can ensure that the subpanel installation is safe, reliable, and code compliant. This ensures the lighting panel will operate as intended and reduce any safety risks to persons or equipment. Understanding the specifics of Article 408.21b is critical in determining the correct subpanel size. Furthermore, performing load calculations and considering future expansion will help ensure the subpanel is appropriately sized. Also, always consult local codes and qualified electricians to ensure safe installation. It is also important to have the proper circuit breakers to protect the branch circuits. Remember that electrical work should only be performed by qualified individuals who have the necessary training and experience. This will ensure a safe and reliable installation.